We're live.
Okay.
Okay.
Okay. Hello. Welcome back to a Seed Studio channel. So I'm Kasun.
Hello, everyone. I'm Shu Yang. Today, we are going to dive into something really interesting. It's Raspberry Pi AI. So since Raspberry Pi launched the AI kit and the AI camera last year, it's really cool to see more and more interesting applications popping up. From basic stuff like MobileNet, YOLO, to even attempting to local LLMs. So it's really cool to see, everybody's doing, interesting AI applications around Pi AI. Then, Kasun, how about Seed? What you guys been cooking up?
Yeah. So we are very busy throughout our works. We are working on our innovations,
Okay.
and both industrial and commercial grade AI-based products we are innovating these days. So first of all, that I want to talk about this edge controller. So it has, that it's kind of making with Raspberry Pi CM4 based, and also you can see a lot of rich interfaces here. So it's kind of RS485 and RS280, 232. Digital inputs, digital outputs, and also you can either connect to LoRa or 4G networks as well, right? So I have a kind of breaking news as well. We are working with CAN bus.
Oh, okay. So it's on the way.
Yeah, it's on the way. And
I remember this product. It is featured in one of our previous stream.
Yes, yes, of course. And I think you already know this guy, the HM, human machine interface, with AI capabilities, right? So even it has also RS485 and also a CAN bus and rich interfaces, and also you can connect with LoRaWAN or 4G networks as well. So apart from that, I need to talk about this guy. Could you?
This guy? Okay.
Right. That's the thing, right?
What's this?
Yeah. So it is world's first CM5 based AI computer, mini AI computer.
Oh, okay.
So today is our main character is this guy.
I see. So today's stream is packed. We're going to show this product.
Yes.
Inside and out, and we will show this product, like how to use it and how it is designed.
Yes, of course.
Right?
Yes.
That's awesome.
Yeah.
Can't wait.
Yeah.
So, and oh, by the way, we have prepared a special discount for everyone's watching. Check this, and that's it.
Yeah.
Let's get started.
Yes.
So, I actually did my homework.
Oh, very good.
To prepare for today's streams. So, I know the highlights of this product. Let me show you.
Okay.
So like what you just mentioned, it is the this one is the mini AI PC based on CM5, but not just the CM5 brings more power to the tables. It is equipped with the 26 TOPS Hailo NPU, and this product also has the extra M2 slot for the high-speed SSD. And what else you got here? And 1 gigabit Ethernet port, and also 2 USB, which means that it supports both the IB camera and the USB camera.
Yes.
And an extra mini PCIe for additional connectivity add-on like 4G and LoRa.
Yes.
And then you guys have 2 versions of it. One is the commercial grade, which is based on the Raspberry Pi 5, and the industrial grade, which is based on the CM5. Right?
Yes.
Okay.
Yeah.
And I want to switch the cam to show you, to show everybody the size of it. This one is the Raspberry Pi 5, right?
Yes.
Version. And this one is the CM5 industrial version.
Yeah.
So this is called mini PCIe, but this one is even minier. Yes. It's really cute. Okay.
So can you tell me more about some application scenarios? What we can do with this guy?
Okay. Again, I did my homework.
Yeah.
One of the typical use case will be connecting the camera to our AI PC, which I also call it AI box, and then to do the image and video analytic. Yeah. So one of the classic use case will be using a security monitoring system. You can hook up our AI box to the NVR device and think the applications like target detection or our target tracking or abnormal behavior analysis, or even you can integrate with your with the alarm system and use it as an access control. And another typical use case will be connect our AI box with the store camera in smart retail applications. And for think about like customers counting or tracking or our heat map generation, and even check the status of the queue to predict the wait times, right? So for me, actually, it's pretty straightforward. So all you need to do is connect the camera and then with the AI box, and then flash the appropriate model onto the AI box. Then you're good to go. That you're set, right? Yes. But I'm curious about this. So why local? I mean, why local while you can do everything on cloud, just like many other solutions do today?
Yeah, there are actually two different reasons behind that. So first one is the privacy.
Okay.
So your sensitive data, it is not going anywhere, right? So it means your data is stay on with you.
Okay. And that sounds safe.
Yeah. That's another one is the low latency, which means the real time analysis with zero latency. So that's the two main reason behind of that edge control.
Okay. But local, does that mean less powerful?
How about we jump into a demo?
Okay. Yeah. Then I switch to your laptop.
Yeah.
Okay.
Okay. So can you see? Yeah.
Oh, that's two of us.
Yeah. So they are. Okay. So this demo is actually made with that YOLO V8 model.
One of the most popular object detection
models. Yes, of course. And we connect our USB camera to this AI box, right? And then that's camera feed to the model which is running on the mini PC AI box, right? And the outputs you can see the generated using the COCO dataset pre-trained model, right?
Okay.
So COCO has I think up to more than 80 objects we can detect, right? So you can see the frames per second. Can you tell me frames per second? What is the FPS? Yes, FPS.
26 something, 27.
Yes. Okay. So it's almost a kind of real time.
Okay.
Yes. So yeah.
Can I try with cat?
Of course, of course.
Okay.
Yeah.
Then let's welcome our special guest, Didi.
Where is Didi?
He's the most beloved members. Oh, okay. He's our most beloved member in Seed Office. This person. Before seeing the cat, I think everyone can hear his voice.
Oh. Cat.
Sometimes dog.
Okay, cat. Yes, okay. He's nervous.
Bye, Didi. Okay.
Right. Okay.
What's the meaning of FPS?
Oh, that's a good question. So FPS is basically frames per seconds. So speed that there is, if by chance, let's suppose that there is kind of object detection or pose detection models. So can process the frames with its outputs. That's kind of a simple meaning of that. So furthermore, talking about this, it is actually affected by post-process and also inference and also pre-process as well. So in this example, you can see the FPS is about 27, I think, right? So it's pretty much actually a kind of a high value, and also it is kind of a, so real time because of this NPU architecture.
Okay. So it sounds like the NPU contributes a lot
Yes.
in the to improve the inference time.
Yeah.
Then what is the NPU?
Yeah, NPU is actually a microprocessor.
Okay.
Which can mimic the human brains, and especially is designed to for AI tasks like large language models, and also for a vision based models, like convolutional neural networks related things. I think you might be heard about that.
Okay.
Right. So I need to emphasize a bit more about this. That compare with GPUs, the NPUs has less amount of power consumption. That's the major point we need to emphasize, right? So I think you might be heard about Corals.
Yes.
Coral TPUs.
Yes, a lot of people using.
Yes. It's pretty much same thing. Yeah, same thing. Not architecture. Same thing.
Same concept.
Same concept.
Okay.
For the vision-based models,
okay.
Right? But for Coral, I think it's kind of 4 tera operations per second, right? But for this guy, this Hailo got more power. It's 26 tera operations per second.
It pushed up to 26 TOPS.
Yes.
The number sounds really good, but then I want to know what it means in FPS. So I have a test report here that I want to show. This is a test report from you guys' team.
Yeah.
And I see that this benchmark test is based on the YOLO VAS object detection model and the pose detection model. And you guys run it both on the Raspberry Pi 4 or CM4 and Raspberry Pi 5 and compare the performance both with Hailo 8 and without the Hailo 8. And if we take the object detection as an example, the FPS is kind of jumped from 0.6 all the way to 145.
Yeah.
That's actually pretty amazing. Yes. But then the FPS is not a fixed number, right?
Yeah.
It so based on my understanding, it varies based on different factors like different numbers of the camera streams, camera channel, or the camera resolution. All may affect this FPS, right?
Yes. So could you please move to the next slide?
Yes, okay, this one?
Yeah. So we have tested multi-stream video processing in FPS. So it is kind of an inverse relationship. You can see, you can test 1, 2, 4, 8, 12 channels. So different FPS can be obtained. So when the channel got increased, the FPS get decreased.
Okay.
So it's kind of for the large deployments who wants to build up, we make that kind of data.
Okay. Awesome. Speaking of this power consumption, so this brings up a really interesting point. Raspberry Pi has always been the go-to option for a lot of developers in the IoT application, embedded IoT application, because it's low power consumption. But if you add all this AI muscle onto this, will that, like, doesn't it create a huge power drain?
Actually, we haven't completed our power consumption testing on this CM5 based mini PC AI box, but we have do some testing with 13 TOPS, the Hailo 8L model. So could you please switch?
This one?
Yes.
Okay.
Yes.
I see. Okay, so I see what's happening in this number. This is the power, and this is the FPS.
Yeah.
And for the power, the yellow one is the Raspberry Pi 5. So the number here is 10. And for the first one, this is the Raspberry Pi 5. plus the Hailo AL13 tops. So I can see here it's actually using less power.
Yes.
But the efficiency, which is the FPS, is raised from the 0.5 to the 93. So if so I think it is because the NPU kind of take over the workload from the CPU, so to achieve that lower power consumption, but at the same time to like significantly to improve the efficiency.
Yes.
Okay, yeah. That's pretty awesome. Looks really nice.
Yes.
Okay. But with all this, powerful features, is it complicated to use?
Okay. So actually, Hailo gives you a lot of guides. It's kind of a software suite, right? So it has contained lot of data flow compiler, and also some kind of model zoo, the rich model repository you can go through with that, right? For different vision based tasks, right? And also they give some kind of runtime inference as well. So all those things it makes much more easy, but you know that our
it sounds like a comprehensive tool chain, isn't
yes,
it?
comprehensive, okay. Yes, and our development team has made a kind of a guide, a zero to hero AI course.
Okay.
Okay. So anyone can be a master of AI.
Okay.
With this course. Okay.
Okay.
So, so it's actually beginner friendly. So
okay.
everyone can start it with zero knowledge. Okay.
Can I see it if it's from 0 to hero?
Yes. Let's go to the.
Okay. Yeah. Switch to your screen.
Yeah.
Okay.
Right. This is our course, right? Right. So we will put the link on our comment section, I think.
Okay.
Yeah. So I would like to ask our spectators to come and play around with this course. So yes. What's your problem now? It's a kind of what?
Okay. Yeah. Chapter 3. Okay. CV projects and practical application. How about we run some applications if you already got some here?
So, okay. So, so everything in the what do you call that in our course guideline has detail explained, and you need to install some kind of tools before you run these models.
Okay.
Right? So after that, if you properly install your models, the tools. So within a single line code, you can play around. So for example, so I'm going to run a detection model, right? Detection model, and you can see the source is 0. 0 means which means we are using now is the USB cam.
I see.
Yeah.
So if you switch to let's say source 1, then that's another camera source.
Camera source. Yes.
I see.
Yeah. So let me run. Right. So like that, you can run the models.
Okay. Chair, person, laptop. Okay.
Yeah.
Then can you change the source?
Yeah.
Or like change a new model.
Models. Like I think that's better to change with new models.
Okay.
Let me run models. So how about pause?
Okay.
Pause estimation. Okay.
Sounds good.
Yeah. Right. Pause estimation. Okay.
Okay. Okay. Here.
Yeah.
Okay.
So it's almost you can feel that it's kind of real time.
That's very intuitive.
Yes.
But then, do you have an even easier way?
Yes, we have built a kind of graphical user interface. It's actually a web graphical user interface. Particularly, we build with Flash. You know that Flash is lightweight, what do you call that, a web development framework with Python, right? And also we use kind of open CVs as well. So, so let me run that. Yes. Okay. Here we go again. It's a single line code. You can follow our tutorial in our chapter 6. This is mentioned.
Okay.
Right? Okay.
Chapter 6.
Yes. So let's go. Okay, and survey started. Right. Object detection. Oh, let me try with object detection first. Okay. So
how many models that you support?
So actually YOLO V8, YOLO V7, and also I think 9. So some part of that, even you can make your own custom models.
Oh, I see. Okay.
And also mobile net also support. Okay. Right. And yes, YOLO V8, select, and label files, which comes from again Coco dataset. So I am using that dataset. So start object detection. So I'm going to use camera. Okay.
Ooh.
So if you don't like this, what do you call that?
Okay.
Command line interfaces, you can try this.
Yeah. Cool. Yeah. How about try another model?
Let's go for the vision-based task of force estimation, right? So for the force estimation, let's go for this force. Right, and also I'm going to again use camera.
Okay.
And start force estimation. Right. Okay. Say hello.
Hello. Okay.
Okay.
So I see another source, which is the MP4 one, which means that you can also try to upload a video right, to test it. That's a pretty intuitive tool to kind of test the model and test our device out.
Yes.
Okay. Cool. Then are all of the model now you're trying are supported by the Hailo Model Zoo that you just mentioned? Then how about the model that out of the Model Zoo?
So out of model, so yes, apart from that, we are using tools. There are tools to make kind of OCR, or optical character recognition model. So shall we jump to that demo?
Oh, okay. So you have an OCR demo.
Yeah.
Okay.
So again, I'm going to run this. Okay. So could you?
What's this?
Oh, this is a bill.
It's a bill?
Yeah, bill. A bill sample.
Okay.
Yeah.
The camera source is this one, right?
This one, yes.
Okay.
Okay.
Let me take this down.
Okay.
So what we got here? Okay, shirt. It's a receipt.
A receipt, yes.
Terminal 1. 1 shirts, watch, pants, socks. And the price. Oh, it cannot recognize the dollars. The dollars.
Dollar sign.
Yeah, dollar sign. Okay. Cool. Thanks for showing this. All of these models are vision based. Then how about sound, audio?
That's a good question, but stay tuned for more updates because we are, what do you call that? We are working on that.
Oh, okay. So it's gonna support, right? That means awesome. Then I can imagine that if you combine the vision AI and the sound AI, with the IoT, like the smart home and smart building, it's gonna take this to next level.
Yeah. So actually, we have that kind of demo about with the Frigate. The Frigate, the NER. So in this AI box, also we install Frigate. Right?
Ah, okay.
Yeah. So let me show.
But you say you haven't finished.
Yes, we haven't finished. Actually, we didn't integrate with HA, Home Assistant.
Okay.
But imagine that you can do this kind of stuff like in your home there is a specific area for cats, right?
Okay.
In there maybe a cat feeder, and when cat comes to that nearby place, the cat feeder is automatically on. Likewise, those kind of automations you can done with existing your home assistant system. You don't need to what do you call that, change too much.
I see.
Yeah.
That sounds awesome. Thank you for the sneak peek. We can show this like next time.
Yes, of course.
Okay. Yeah. Then thank you for showing all these powerful features and demo with us, Kasun. But now I am wondering how it is developed, like how it is designed. What's inside?
Yes. Shall we move into that? Let me clean my table.
Okay, you want to show the products, take it apart?
Yes, we need to disassemble first.
Awesome.
Yes. Let's
Sounds
go.
good.
Okay.
Let me switch to the desk, to this camera.
Yes.
You want to unplug this?
Yeah, unplug. All the unplug.
Okay. Just.
Okay.
Let me help you. Okay.
Yes.
Oh, a Coca-Cola.
Coca-Cola, yeah. Don't drink now.
Oh, okay.
Right. Okay.
Yeah, unboxing.
Yes, unboxing.
What's in here?
Yeah.
Okay, a cable,
cables.
power adapter.
Yeah.
Okay. Okay.
So let's unbox it.
Oh, I see. There's a certification.
Yeah, certification.
Actually, I've already finished for this product. I see FCC Rose, Talak.
Yeah.
Okay. Okay. Oh, wait.
Okay.
I think we can compare the size of it.
Okay.
Okay, so this is a slim Coca-Cola can, and if I compare this, it's shorter, and the thickness is around the same.
Yes.
Okay. Oh, then how about the mini one? Sorry, the mini one. Oh, it's pretty mini.
Yeah.
Okay, the
thickness.
thickness.
Even smaller.
Yeah, even smaller. Cool.
Okay. Okay, could you help me to push this?
Let me help.
Yeah. 1, 2, 3. Right.
Kasun, do you know what's this?
So it is again aluminium bar to conduct heat.
Oh, I see. So it's for the heat management.
Yes.
Okay. Let me see. Okay. The antenna port. Yes. Oh, this screw is for the for this metal.
Yeah.
Okay.
All right.
Oh, all right.
All right. So, okay. Right. Me. Yes.
You unplug this one. I unplug this one. Okay.
right?
Okay.
Right. So, so okay. I will yes. This is our Coral 26 top. Sorry,
Hailo. Okay.
Hailo.
This is the M.2 connector.
M.2 connector, and
Okay.
also
can I use other MPU?
yes, you can use DeepX as well.
No, I mean, so for example, if I wanna, I have the need to scale up or down the computing power, which means that, for example, if I want to use 13 tops or all the way to
you mean
like 200 tops.
Customization.
Yes, customization.
Yes, of course, we can do that.
Okay,
yes.
Then it support different MPU.
Yes.
Okay.
And this is that CM5 computer, and also we can see the antenna interface as well. You can connect this slot for the wireless connectivities as well. And let's go to the back side. Yeah, so you can see USB ports, USB Type A and USB
for
type
USB camera or other USB devices. Okay.
Yes, for C, USB Type C, and power, and Ethernet, and two standard HDMIs, right? And this one is another again mini PCIe slot for a different what do you call that LoRa connectivities.
Okay.
And also 4G connectivities. You can adapt this. And this one for the SSDs, you can connect SSDs as well and boot from SSDs. Okay. Right. So yeah. So
how about this?
So yes, this is the SIM card slot.
Okay.
SIM card as
okay.
Well. Yes.
And this?
This is that there are what do you call that the in case here.
Okay.
So there are LED indicators.
Okay.
So you can power or users and the connectivity is working on.
Okay. So it's for status.
Status.
Okay.
Yes.
Cool.
Yes. And this one for the cooling fan. Right. I will talk about cooling fan later.
Okay. Yeah. So how you? Yeah. So you're going to show us like how you guys manage the heat, right?
Heat. Yeah.
Okay.
Yes. Okay. Right. So we have actually kind of that do multiple heat dissipation solutions were designed evaluate through the simulations considering.
Okay. Yes. I think I have prepared this.
Yes.
Okay.
Yes. That's what I mean.
Okay.
So what we have done is radiator structure and copper tube layout optimization and also PCB device layout optimization and airflow path optimizations.
Okay.
Yes, each solutions was analyzed for the temperature distribution and cooling efficiency. Okay. So which means this leading to make us to find the optimal thermal solution.
Okay.
So key advantages I need to mention first here why we that you already mentioned this is a Coca-Cola size, right?
Okay.
Yes. So why this kind of solution is important to us because we need to efficiently components manage, right? So that CM5 and the Hailo is the main heat sources. So it's
that's this one you're talking about.
Yes.
This two there and the main heat
generators.
Right? Okay.
Yes. And that so we position this on top of the PCB like this, right? And to minimize the thermal part to the radiator and enhance the heat conduction.
Oh, okay.
Right. So optimal radiator design. So this is the radiator, right? Design.
Okay.
So we have an active cooling fan.
Okay.
But that you can see there is no pins and low for the low airflow.
Okay.
Right. So the heat is generating components are placed in like this left and right side in the PCB and pinned area.
So you kind of match the pin.
Yeah.
Position.
Yes.
Okay.
So pin area for the high airflow improves the heat dissipation efficiency.
Okay. Have you guys conducted any tests? So after you find the optimal
yes,
design in the simulation?
Yes, could you please, yes, that part. So we have actually tested for low temperatures and for the high temperatures as well. It is very well with standards for those kind of harsh environments, right? So you can see in here even in minus 20 Celsius degrees, and also for 60 degrees. So which means that it is with standards for very harsh environments as well.
Yeah. Okay. Then, okay, cool. So I think that's what's inside it, right?
Yeah.
Okay, awesome. So I think that's all for today. Do we miss anything?
I don't think so.
Okay, then that's so I can tell that you guys really put a lot of thoughts in this product. Yeah. Thank you very much, and thank you, Kasun, for sharing with us all these wonderful insights.
Yes.
And should we take some comments or questions? Okay. Then I think our teams in the comments covers everything.
Yeah.
Then that's all for today.
Yeah.
Everyone, that's all for today, everyone. So if you're interested in AI device, remember to subscribe to Seed channel, to subscribe to our channel, and see you next time. Thank you for watching.
Bye-bye.
Bye-bye.